You guys will be able to find and interpret measures of central tendency 12.3 on this Fun Sock Friday. So, measures of central tendency. It is a value that describes the center / middle of data. So when you have a lot of different data here, like maybe you went and collected something for some sort of study, or maybe you're just saying like, what's everybody's favorite restaurant? Or maybe like on a scale of 1 to 10, how would they rate some sort of service at some sort of restaurant, and you're collecting all these numbers, all this data, and you want to know, well, how do we measure this well? How do we say, what's the average? What's most common? What's most repeated? What's the highest number? What's the lowest number? Are there any numbers that are like way off base? Like everybody said something was really good except for 2 people said it was really bad. Like what do we do with that information, okay? That's all stuff that deals with what we call central tendency. So we have the mean, okay? The mean, it can be abbreviated as such with a symbol. It looks kind of like a U with a tail at the beginning. It's really weird. I'll be real. It's like a U with a tail at the beginning. Mean is what we call the average. It's the mathematical average of everything. The mean is found by adding up everything and dividing by however many things there are. The median is the middle value. Have you guys heard of medians for like the road before? Where's the median on the road? I put away. Where's the median on the road? In the middle. So would it make sense that the median for math is the middle value? So when you line the data up least to greatest, we say, hey, whatever is in the middle, that's the median. And then the mode, or modes, depending, is the most repeated value.
Good thing we're learning this because I had on my math test like every other question. I didn't know any of them. I never know how to do mode. I can't do median.
Yeah.
Or mean. I can't do that either.
Well, now you'll know. So, directions. Find the mean, median, modes for each data set. Okay, I'll give you guys some calculators here. Does someone want to volunteer to sanitize and pass them out? Okay, go ahead, Abby. Sanitize and pass out the calculators, one to each person. You can take the box with you. All right. So, to find the mean, you have to add all these numbers up. So we add up 58, 53, 59, 51, 46, 35, 51, 58, and 60. You add them all up, and then we're going to divide by however many numbers there are. So, while we're waiting on the calculators, let's count how many numbers there are.
I don't want blue. Well, you already touched
Yep,
it.
Brady's correct. There are 9 numbers. So we're going to divide by 9. Those who have your calculator, go ahead and start adding up these 9 values. Thank you. And once again, now that you have your calculator, go ahead and add up these 9 values. 58 plus 53 plus 59 and keep going. After you get it, write it down on the top of the fraction. Okay, raise your hand if you want to share the sum of the numbers you got. Okay, Brady?
471.
I would agree. 471. If you didn't get 471, you must have made some sort of mistake as you typed it into your calculator, which does happen. So you take 471 and you divide by 9. So take that and push divide by 9 in your calculator with it. Yeah, and you end up getting 52.3 repeating. So we're going to put 52.3 with the repeating bar above it. That is our average here. That is our mean. Questions on how we found the mean? All right. Let's look at the mode, or excuse me, the median and the mode. The best way to find the median is to order the data least to greatest. Now, personally, I found it to work best like this. Look through the data and say, what's my smallest number? 35, right? So I'm going to write 35, and then here's what I'm going to do. I'm going to cross out the 35 in the original list, so that way I know I've already dealt with it. And then I say, okay, what's my next smallest? 46. Cross it out. Next smallest. 51. What's my next smallest? Same thing. There's two of them. What's my next smallest? 53. What's my next smallest? 58 and 58, so two of them. Cross them both out. Next smallest. Next smallest. 60, and we're done. So see how crossing them out might be helpful for you to stay organized here? Okay, it's a tip I really advocate for and would highly suggest to you guys to cross them out as you go through like that, so that way you know you covered all of them. Now, as we count through these, which one lands in exactly the middle here? 53 does. So what's that make our median then? 53. That is the middle number. Now, is that slightly different than our mean? Yeah. Then the mode, we say, well, what number or numbers are repeated the most? 51 as well as 58. They both are. So we write them both down. Those are the most common two numbers. So when I grade your guys' test and I put it into Infinite Campus actually will tell me what the average is. And so I can go on and see, I can see the average. That's the mean. It shows me the average score for a test. I can look through it. I can see, what was the most common score, though? What did most people end up getting? Oh, most people got this score, okay? And then what was the score that was right in the middle? I can go and find that as well. Any questions on those three? Okay, I want you guys to try and find those on number 2 here. So, exactly. If we add up for the mean here, the mean ends up being 228 divided by 12. To make sure you got it correct, you can take 228. And if you didn't get 228 on top, that's probably where you made the error. And this ends up just being exactly 19. No decimal this time. To find the median, I would once again find it helpful to organize. Get 7, 10, 11, 15, 15, 19, 21, 24, 24, 24, 27, and then 31. Now for the median, we might notice there's exactly 2 numbers in the middle, because both 19 and 21 are 6th and 7th. And those are both in the middle if we count inward. So what do we do when there's 2? You actually go halfway between those numbers. So what's halfway between 19 and 21? 20. Now if you're having trouble finding halfway, mathematically what that means is you take 19 plus 21, take the 2 numbers added together, and divide by 2. You find their average. The mode, what's the most common number we see here by far? 24, right? We see 3 of them, versus only seeing 2 of the 15. Okay, any question on that? All right, continuing on. Measures of variation. So we want to know how much things can vary from the mean. Because we had the mean here of 19. But was every number really close to 19? Was every number really close to 19 on the last problem? We had all the way down to 7, all the way up to 31. On this first one, we had our mean was 52.3 repeating, and we had all the way down to 35. So sometimes we want to know how much does it vary from the center. Is it all over the place? Or is everything pretty well about the same? You know, did I have on my test, did I have some people do really well and some people do really poorly? Or did everyone kind of perform about the same on this test? It's helpful information to know. So measures of variation is a value as well, a value that describes how spread out a set of data is. Saying, hey, how far out is a spread? Is it clumped, all close together, or is it all over the place? So, one thing we do is called the mean absolute deviation. Mean absolute deviation. This is the average distance that each value has of the mean. So it's the average distance of each value to the mean. Saying, hey, how far is every single value from the mean? And then average it. Meaning what you have to do to find the mean absolute deviation, or MAD, and maybe you're mad that we're doing this, okay, is we first have to find the mean. So if we find the mean of these 6 numbers, 85, 74, 88, 80, 92, and 60, we add them up and divide by 6. And what does my mean end up being? Let's go to 2 decimal points. And feel free to answer it when you get it. That might be your sum, but go and divide now. I would agree with that. 79.83 would be our mean right now.
That's 71.5.
I got 71.5.
Okay. Okay. 79.5 you said? I think we might have typed something in wrong. Try typing it in one more time. Okay? So now what we do is this formula, it's pretty messy. Essentially what it's saying is take the mean, or take the number and subtract it from the mean. But we want the absolute value so it's positive. Who's care how far away it is? So we want to know how far is 85, the first number, from the mean. So take 85 minus 79.83.
5.17.
Okay? So 5.17, write that down. And we're going to add that to the next one. So now we take 74 minus 79.83. So we take 74 minus 79.83. Now you're going to get a negative. Ignore the negative sign for this. Okay, this is the one time I'll tell you to ignore the negative sign for this, because it's the absolute value of it.
5.83.
Okay, 5.83. Plus the next one, 88 minus 79.83. 8.17. Plus the next one, 80 minus 79.83. 0.17, 0.17 if you prefer. On to the next one, 92 minus 79.83. Yep, 12.17. And the next one, 60 minus 79.83. It's our last one of these. And ignore the negative again, because we just want to know how far away it is. We're not concerned whether it's positive or negative. 19.83. So what we did was we said, hey, how far are each of these numbers from the mean? Now what we do is we add those all up and we divide by however many numbers there are one more time. So it's a mean of these numbers. It's an average of these numbers. So you find out the mean originally, then you say, okay, how far is every number from that? You add all those up and divide by the same number you divided by earlier. So type in your calculator, divide by 6. We're going to get a decimal again. Okay, 8.5, and it should be 8.56, I believe. Okay, yeah, depending on where we round.
I got 8.55.
8.55, but it rounds up to 8.56. Is that correct? If we round the 2 decimals, does it round up to 8.56?
Yeah.
Okay. And so the number on top of my fraction I got, by the way, was 51.34 divided by 6. So a little way you could check your work there with me. So what that's saying is, on average, these numbers were 8.56 away from the mean. That's what that's telling us. These numbers on average were 8.56 away from the mean. The higher the number, the farther spread out everything is. The lower the number is, the less spread out everything is. Any questions on that? Okay, we're actually going to skip example 4. And move on to the next page. We're going to talk about variance. Variance is this weird little symbol. It's kind of like an O, but it's acting like you're going to go to the next letter in cursive. Some of you guys don't know cursive, I guess, if you didn't go to St. John's probably. So it's like the O, and then you do a little tail on the top. They did teach you? Okay, good. Oh, that's good. Okay.
Our third grade teacher did like a page every couple weeks. Yeah.
Oh, okay. So kind of. So it might look a little familiar, like an O with a little tail at the end on the top. Okay. Maybe an O with like a flat bill, a hat, brim hat or something like that. Okay. Anyway. A visor. An O with a visor. That's the word I was looking for. Variance. It is the average squared, hence the square on it, distance of each value to the mean. So it's a very similar idea to what we just did with mean absolute value distribution, where you say, how far are each of these numbers from the mean? But the only difference is, when you say how far is it away, you actually square that number before adding it to the other numbers. So you square each of those numbers that we just found. So what we would have done here is we would have taken 5.17, square it. 5.83, square it. 8.17, square it. 0.17, square it. So on and so forth. Add all those up and divide by 6. That's how that's how the variance would work, excuse me. Now you might notice, what's the symbol with variance and standard deviation? What's different between those two symbols? One's squared, one's not. So standard deviation, we're going to define it as the square root of the variance. Now I want to note here that the standard deviation actually, this is what's considered to be the most useful measure of what we call dispersion. Dispersion is just a fancy word saying how far spread out they are. Okay, dispersion is a big fancy word just saying how far spread out are they. Standard deviation is actually our most useful measure of that. So what do these numbers mean? Because we can find these numbers, but what do they mean? Well, the lower the standard deviation is, indicates that the values are closer together. AKA, they're less spread out. Whereas a higher standard deviation is going to mean the opposite. The values are more spread out. So let's do one example of it this way, and I'll talk about what we can do after that. So let's first find the mean, because we need the mean in order to do this. So remember the mean, we're going to add these numbers up and divide by however many there are.
This fell back to 1 5.
Yep. I would agree, it is 92. The mean is 92. Okay? If you add up those 5 numbers, divide by 5, you get 92. Now, in order to find the standard deviation, in order to find the variance, Let me go back again. I'll finish the first sentence I started. In order to find the standard deviation, you need to find the variance and square root it. So to find the variance, which is that little O with the visor squared, what you do is you take each value, so our first value is 85, you subtract the mean, and you square it. So notice I put that in parentheses. You might want to write this down on your paper as well, okay? I'd write decently small, because we're going to be writing a decent amount on this line, just so you know. Like I probably need to write it smaller. Plus the next parenthesis, which is going to be the next value, 88, minus 92 again, the mean, and square that. Plus, does anyone want to guess what's going to be in my next parenthesis?
91 minus 92.
91 minus 92, yep.
Squared.
And it's going to be squared. So we're just going to keep going through it with each value minus 92. Add it to the next one, 96 minus 92 squared plus 100 minus 92 being squared. Now all of these would be over 5 again. You would still divide by 5, just like we did the last time. Oh my goodness, that's a lot. Now what might be helpful here for you is one more step in between. Let's do all the subtraction right away. What is 85 minus 92? Negative 7. So that's going to be a negative 7 being squared. What's going to be a negative times a negative, though? Positive. Okay, that'll help us out. Plus 88 minus 92. Negative 4. Once again, a negative being squared is going to be a positive. 91 minus 92. Negative 1, which once again, a squared is going to make a positive. The next parenthesis, 96 minus 92. 4. This one's already positive. And the last one, 100 minus 92. 8. Divided by 5. Now, once again, this is just a lot of process. Okay, this is a lot of process. None of this math we're doing right now is so overwhelming to where any individual step is overwhelming. But what could feel overwhelming is how many steps we do. Well, how am I going to remember a formula, blah, 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 blah. And that's what's going to be probably our hang-ups with these. And so if we square all these numbers and add them together, well, first we just square the numbers. You get 49 plus 16 plus 1 plus 16 plus 64 divided by 5 again. And that's going to make your life a little more manageable there. So you can take 49 plus 16 plus 1 plus 16 plus 64, all divided by 5.
I had 29.2.
29.2. So you have to take those 5 numbers divided by 5. 49 plus 16 plus 1 plus 16 plus 64. Yeah, Brady.
I did the whole thing.
Like you typed all of this in your calculator?
Yeah.
And you can do that. Did you still get it?
Yeah.
Yeah. Hey, so did you hear Brady? Brady said, Mr. Kossel, I typed in this entire thing into my calculator divided by 5. And I still got the right answer. You can do that. What you have to be careful of is make sure you don't miss a single thing in your calculator. If you miss a single thing, it throws it off. But if you catch everything in your calculator, all the parentheses, the minus signs, the squares, plus signs, you name it, you'll be fine. You can type that all in your calculator. It'll do all the work for you. Now square root that number. So take the square root of 29.2. And we'll round to 1 decimal place.
Where would we do that?
5.4. The square root is second, and you hit the x squared button on the left hand side. So you take 29, you hit the square root button, which is second, and then x squared. And then you type in 29.2 and hit enter. So yep, hit second, then hit the x squared button. You get square root. Okay, so this is saying the standard deviation will be 5.4. Okay. We're going to talk about a way to make this easier. You'll like this. Once again, time-wise, we're going to go over the calculator thing in the rest of the section next class. Okay, that'll be next Tuesday, next Tripartite Tuesday next week. Okay? I'm going to assign a little bit of homework with this. We're going to assign the rest of the homework with that. And then, on Tuesday, we're going to finish up these notes, finish up the homework, and I'm going to give you a quiz review. Okay? You're going to have the rest of the class work time after the notes are done. The rest of the class work time, and it's just part of the notes. Okay? So it'll actually be some work time this time. Okay, I know you guys haven't been getting much lately. I'm sorry about that. But we'll actually get some work time next time. Good amount. And then, when you walk into class on Thursday, we're going to start with a quiz over these 3 sections. A quiz. It's going to be a big homework grade. So it's not going to go in as a test grade. It's going to go in as the equivalent of a few homework assignments, okay? So it's worth more than a homework, less than a test. Okay, we've had some quizzes in here first semester, okay? And then we're going to spend the rest of the class reviewing for the final. Okay?
The quiz is going to be over everything.
I'm going to write it on this section so that way we can actually see it. For now, I want you to do numbers 1 and 2 fully. And I want you to do on 3 through 6, just the MAD, the mean, absolute distribution. Mean absolute deviation. I said it wrong. Okay, so 1 and 2, do fully. 3 through 6, just do the mean absolute deviation for now. Okay, we'll come back and finish the rest of it next time in our work time, okay?